All right, we're going to start off with a conversation or a review of the rectangular coordinate system. So hopefully this um, feels familiar, even if it's been a few years since you took math. Hopefully you remember these kinds of scenarios, and this is the right place. So the rectangular coordinate system. Now, before I really begin, I do want to remind you this is recorded. I do tend to talk fast. I apologize. I've been trying to control that for 10 years, and it's not working. But because this is recorded and it's a video, you can pause, you can rewind, you can look at it again. So if you want to just watch it once and then go back and take notes the second time, that's okay too, or vice versa, if that's what helps you remember the material and get it. Just keep in mind you are able to do all of those things, and I would encourage you to do so if you need to. Okay. Our rectangular coordinate system, this is our Cartesian plane. It is sometimes called a coordinate plane, right? You have your x-axis, you have your y-axis. We graph coordinate pairs alphabetically, and by that we mean when an ordered pair is written, it's written as x comma y. So we go horizontally and then vertically, so x some distance, y some distance, and then we land at whatever that point is. Same thing could be done in any of the four quadrants. Okay, so I could go 0 and then backwards, where now I've got an x and a y. I could go down and backwards, etc., etc. Okay, so we can navigate this space by attaching a coordinate to the locations. And you can think of them like steps. Like if you're standing where you are and you're trying to tell someone how to get from here to over there, you could say, oh, well, go this many steps to your left and then go down this many steps, or, however it works out. And that would kind of give us this sense of I can now go in a direction, or I can now relate this place to that place. And when that really leads up to is eventually we get to the point where now I can say things like, oh, well, all of these points have something in common. And because they have something in common, I can assign them an equation, which is awesome. I want to be able to do that. Okay, so math is all pattern, 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 pattern. And so this is where our patterns start. Now you may notice that the quadrants are numbered funny. I go from quadrant 1 to quadrant 2 to quadrant 3 to quadrant 4. And the reason that they're labeled counterclockwise like that is because eventually our goal is to take this rectangular system and be able to interact with trigonometry and geometry and all of those things so that we have this common thread through all the math. And when we do that, we label degrees, we measure degrees in that same direction. And so we label the quadrants the same way we label those degrees, so that eventually when we start talking about degrees, and we won't do that in this class, okay, so don't panic, that's not in this class, but when we start talking about those degrees, we already have this foundation of thinking counterclockwise, okay? And the last thing that we can really talk about that links these things in red to the things in blue is this idea of points being collinear. Now, points are only collinear if there are 3 or more points that can be joined by a single line. Okay, so for example, these 3 points would be considered non-collinear because there's not a way for me to draw one straight line and hit all 3. These 3 points, pardon my awesome line drawing skills, would be collinear because I can draw one line and I can hit all of those points. And so it's not a word that's very common, It gets used pretty much only in math, but that's what it's asking us, right? And if I can start to join them in a line, then these collinear points can start to eventually form those straight lines that we end up graphing later. Okay. All right. So as we get to those straight lines, as we start to talk about those graphs, the next thing we need to know is how to graph them. And the first technique I'm going to show you works with every single function. It doesn't matter what the function looks like. You can graph every function this way. Now, some of you may remember how to graph the 2x plus 1 by starting at -1 and counting up and over by 2. That's fine. Okay, we're going to come back to that too. But the purpose of this particular slide is to show you that it doesn't matter what equation or what function I'm looking at. I can make a table and I can still get enough points to maybe guess what's going on. Now, the purpose of this class is that we are eventually going to learn some of the shortcuts to graphing each of these. And by that I mean we're going to learn, well, if I look at x cubed, I'm going to have an idea of what shape that should have. And then if I graph a couple of points, I'll be able to kind of sketch the shape without having to graph a ton of points. If I look at 3x squared minus 4x plus 2, my brain, or our brains eventually, are going to see, oh, that's a U shape, that's a parabola. So if I know a couple of points, and I know that there's some symmetry, and I know a couple of other little facts about it, I can sketch these graphs really quickly without having to make a table. So that's kind of about 50% of what we're doing in this class, is we're trying to get to some of those properties, some of those shortcuts, so that I can then use these as models. Okay. All right, I'm going to get this out of the way. So let's say I want to graph something. 2x minus 1. My recommendation, my expectation, is that I know that graphs exist on the right side of the axis. I know they exist on the left side of the axis. And eventually, when we get into the word problems, a lot of times they want to know what happens right at the axis. So I always use 0. Now, beyond 0, you can use whatever points you want. Let's say I want to use 2 and 6 over here. I want to use -3, -4. That's fine. Okay. So what we're going to do with this 6, well, I should slow down 1 second. These points are arbitrary, meaning choose them yourself. It doesn't matter what they are. Choose ones that look like they're going to be really helpful. If you're cubing or raising something to the 5th power, use little numbers so that when you raise them to big powers, they're still relatively small, right? If you have a fraction and the fraction wants you to divide by 3, then use like 3, 6, 9, 12, so that when you divide it by 3, you get whole numbers. You get to pick them however you want to pick them. It doesn't always have to be 1, 2, 0, and -1, -2. That's fine. Use what seems like it's going to make your life easier. Once you choose them, what we're going to do is we're just going to plug them in for that x value. So this is going to be 2 times 6 minus 1. So I have 12 minus 1, which is 11. This is 2 times 2 minus 1. So I have 4 minus 1, which is a 3. This is 2 times 0 minus 1. So I get 0 minus 1. This is 2 times -3 minus 1. So 2 times -3 is going to be a -6. Minus 1 is -7. And then 2 times -4 minus 1 is going to give us a -9. So cool. I have this table of values. Doesn't really help me a lot, except that it does. Okay. This 6, 11 becomes a coordinate pair, right? Coordinate pairs are x comma y. So 6, 11 is on that graph. 2, 3 is on that graph. 0, -1, -3, -7, and -4, -9. So then I can come over to my graph and I can say, all right, -4, -9 is about here. -3, -7, 0, -1, 2 and 3, 6, let's see, 1, 2, 3, 4, 5, 6, and 11 doesn't fit. It's actually up there somewhere, right? And then I can just connect all my points. And even though I didn't draw the rest of those points, I know that they're on that graph. Okay, so you can get a picture, more or less, of what this graph is going to kind of act like. And once I know what the picture looks like, then I can start to say, oh, well, it's increasing, it does whatever, right? So, and we'll get to all of that. We'll come back to that idea. Okay, now I can do this for any function. So let's look at another one. This doesn't, there we go. All right, so let's take y is 3x squared minus 4x plus 2. Now I see that I'm going to square something, so I'm going to pick relatively small numbers just so I don't have to square a lot of things. So I'm just going to say 1 and 2, -1, -2. So plug in a 2. I have 3 times 2 squared minus 4 times 2 plus 2. Now we always square this 2 before we multiply by 3. So this would be 2 squared, which is 4. 4 times 3 is 12, minus 8, which is 4, plus 2, which is a 6. Plug in a 1, so I have 1 squared, minus 4 times 1, plus 2. So 1 squared is 1. 1 times 3 is 3. 3 minus 4 is -1, plus 2 is +1. Plug in a 0, then I have 3 times 0 squared, minus 4 times 0, plus 2, which gives me a 2. 4 times -1 plus 2, that should be a negative. So -1 squared is 1. 3 times 1 is 3, minus 4 times -1, which is a -4. So that's going to be 3 plus 4, which is 7, plus 2 gives me a 9. -2, 3 times -2 squared minus 4 times -2 plus 2. And since I have room on this one, -2 squared is 4. 4 times -2 is -8. So we're subtracting -8, adding 2. So this is 12 plus 8 plus 2, which gives us a 22. Okay, so I've got 2 and 6, 1 and 1, 0 and 2, -1 and 9, and then -2 and 22 doesn't fit. Now you'll kind of notice these don't make a straight line, and they shouldn't. Okay, anytime I have anything bigger than x to the first power, it's not going to be a straight line. So the best I can do is kind of say, well, maybe it looks something like that. Close enough. Right? And that may not be exactly what's happening, but it's close enough. Okay. All right, so let's take x plus 3 over x minus 5. Now, I see down here that I have to subtract 5. So plugging in a 5 there, probably not going to be a good idea, right? Because it's going to give me a 0, and I can't divide by 0. So I'm not going to use 5, but I can kind of just pick any other number I want. So let's say I want to do 0. Let's just do -2, -1, 1 and 2 again. All right, so -2 plus 3 over negative 2 minus 5 is going to be 1 over negative 7. So that's the point negative 2, negative 1/7. It's going to be really, really close to the axis, but not that far away. Actually, I'm going to have to do this. Let's say, I'm changing my mind because you wouldn't know this part just yet. All right, so negative 1 plus 3 over negative 1 minus 5. Negative 1 plus 3 is a 2. Negative 1 minus 5 is negative 6. So that's negative 1/3. So negative 1, it gets just a little bit farther away. Okay. If I plug in 0, I get 0 plus 3 over 0 minus 5, which is a negative 3/5. So again, just a little bit farther away. 6 plus 3 over 6 minus 5 is going to be 9 over 1. So that's a 9. So 5, 6, and 9. And then 8 plus 3 over 8 minus 5 is going to be 11 over 3. So if I go over to 8, 11/3 is a little bit less than 3. Okay, now if we look at that, it doesn't really have kind of that horseshoe shape that the first one had. It doesn't have a nice, look like it has a connected curve to it. So this is why we're learning some of these things in this class. Now remember that I can't plug in 5. Eventually we're going to see that means there's an asymptote there. And in this one, there happens to also be an asymptote horizontally. And this graph actually does something kind of like this. Okay. Now, we're not going to see this again until later in chapter 5, but I just want to show you that the idea of plotting points gives us an idea of, if I know all of these other things, I can sketch these graphs. Okay. All right, now on every graph are these points called intercepts. And intercepts are really nice because if I have linear equations, which means the highest exponent on any variable, sorry, I'm trying to spell that correctly, is a 1. Okay, so I only have x to the first power, I only have y's to the first power. I don't have both, they're not mixed together. Okay, so because of that, if I can find the two intercepts, right, linear equations can be graphed with 2 points. And the easiest 2 points to find are the intercepts. Okay, so for example, if I know it crosses here and it crosses there, I can sketch that graph. If I know a different line crosses here and here, I can sketch that graph. Okay, and intercepts are easy because we are plugging in zeros. Okay, so to find the x-intercept, we set y equal to 0 and solve for x. So let's take that first example. Y equals negative 3x plus 4. So I'm going to set y equal to 0. So instead of a y here, I'm going to plug in 0. Oops, there should be an x there. So we're going to subtract 4 from each side. So negative 4 is negative 3x. I'm going to divide by negative 3. So x is 4/3. And that means x is 4/3, y is 0. So if I were to put that in a table, right, x is 4/3, y is 0, and that's going to become the point 4/3, comma 0. Okay. Now, you don't have to write this table portion, but I want you to see, right, how this would come from the other. You can go directly from x is 4/3 to the point 4/3, comma 0. Okay. Now I'm out of space, so I have to erase some of this to look at the y-intercept. But remember, you can always pause. Okay. To find y-intercepts, button. We are going to set x equal to 0 and solve for y. So y is -3 times 0 plus 4. -3 times 0 is 0, so y is 4. And so this is going to come to be the point 0, 4. Okay, so our two intercepts for this line are going to be 4/3, 0 and 0, 4. Now, intercepts are always an ordered pair. Always, 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 always. It's never just a number. Okay? Now, as soon as I say that, in XYZ, sometimes it just wants the number. On an exam, I want the ordered pair. Okay? An intercept is an ordered pair, so you have to give me the whole coordinate. All right, let's look at 3x plus 4y equals 24. I like to start with the y-intercept. Okay, so I'm going to put x equals 0. So I have 3 times 0 plus 4y equals 24. So 4y is 24, which means that y is 6. So this is the point 0, 6. I'll make note down here. Then I'm going to find the x-intercept. So I'm setting y equal to 0. So I have 3x plus 4 times 0 equals 24. So 3x equals 24, which means divide both sides by 3. So x is 8. So this is going to be the point 8, 0. Okay, we've got one more example where 4y is -3x plus 12. So start with our y-intercept, which means that x is 0. So 4y is -3 times 0 plus 12, which means 4y is 12 and y is 3. So that's the point 0, 3. For the x-intercept, y is 0. So I have 4 times 0 equals -3x plus 12. So 0 is -3x plus 12. I'm going to add 3x to each side so I don't have to deal with negative numbers. So 3x is 12, divide by 3, so x is 4. So that's going to be the point 4, 0. Okay, so for intercepts, whichever intercept you're looking for, set the other variable equal to 0. All right, now the last thing that we want to look at on a rectangular coordinate plane is if I have 2 points, I'll use these 2 points from our graph. So I have 2, negative 3, and I have negative 4, 5. Okay. Now I can take that graph and I can lay it over the top of a map of somewhere, right? Imagine it's on tracing paper and you set it against a map of the United States, right? Every city in the United States is going to have a point. And if I make that coordinate plane, then I can create those points, and now I can start to do something cool. Now I can start to decide how far apart are these places? What's in the middle? How do I get from point A to point B is a different question. But right now, right, we consider this distance, I don't know if you've heard this, as the crow flies, right? If I was able to just, I don't know where these two places are. I'm bad at geography. Let's say Phoenix, and this will be Tucson, right? If I was able to just stand up and fly directly from Phoenix to Tucson, I can tell how far that is because I can use the distance formula and I can get a number. So our distance formula comes from the Pythagorean theorem, right? Traditionally speaking, we go left or right some distance, we go east or west, we go north or south, right? So let's say this is A, this is B, those are the distances I'm looking at. That makes us C. Oh, and we made a right triangle. We did that on purpose. And probably from at some point in your math career, you remember seeing A squared plus B squared equals C squared. Now, yes, I wrote it backwards. Same thing. Okay, I just want you to know it's the same. I just wrote it backwards. All right, so C in this picture is the distance I'm looking for. So I'm going to change that to a D. If I want to find the distance that A is, right, imagine we have that graph here, I would just count these squares, right? Now, I don't have an exact number here, but I do have something that tells me. These are all x values because I'm moving horizontally, right? So this is a horizontal movement, which means it's an x value. So my x here is negative 4, the x here is a 2. So if I want to know the distance between those two, I could just take one of my x values and subtract the other. So instead of a, I have the subtraction of x values. Now, same thing here. B is a vertical distance, which means it deals with y values. And so instead of counting these squares every time, because that means I have to draw a picture, I can just take two y values and subtract them. Okay, so I don't actually want the square of the distance, I just want the distance itself. So let's say I take a square root of both sides. Keeping in mind this is the square root of everything together. Okay, so our distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so when we say it's a derivative, that the distance formula is a derivative of the Pythagorean theorem, this is what we mean. We're saying, all right, well, you have 2 points. Cool. Let's figure out how to draw a right triangle around those 2 points, which we did. And now that I have that, I can figure out a shortcut so that I don't have to plot the points, count the sides, square them, then take a square root after adding them together, right? So instead of all of that, now I can just say, hey, give me the numbers. I got you, right? So let's take these two numbers. So I'm working with negative 4, 5, and 2, negative 3. So my distance is going to be, well, let's make, this will be x1 and y1. This will be x2 and y2, right? Because every point is an x value and a y value. So my distance is going to be x2, which is a positive 2, minus x1, which is a negative 4. squared plus y2, which is a negative 3, minus y1, which is a positive 5, also squared. Okay, so 2 minus negative 4 is a positive 6. Negative 3 minus 5 is a negative 8. And when I square this, 6 squared would be positive 6 times positive 6, which is 36. Negative 8 squared is going to be negative 8 times negative 8, which is a 64. So this is the square root of 100, which is a 10. Now, by way of a hint, to make sure that you're on the right track and that you're doing things the right way as you go, when you get to this step, everything should be positive. If it's not, stop and look at things. If I go to my calculator and I type negative 8 squared, your calculator is doing positive 8 squared and putting a negative sign in front of it. If I go to my calculator and put a set of parentheses with a negative 8 inside, like what we have written here, it will give you a positive 64. Your calculator will do order of operations exactly as you type them in. So you have to be careful when you are putting values in your calculator, because calculators are great, but they are also dumb. So make sure that you are being really careful about how you put those in. Okay? So the distance between these 2 points is 10 whatever units. I don't have units. We're just going to put a 10. Okay? Now, let's say I am in Tucson. I have a friend in Phoenix. I'm trying to meet up somewhere so that we can exchange something. Okay, they left something at my house and need it back for whatever. It doesn't matter. Okay, so just come up with some scenario where I have to get from here to there, and what I'm actually looking to do is meet them somewhere in the middle. Now, Phoenix and Tucson, I grew up in Arizona, sorry. There's a freeway that runs directly from Phoenix to Tucson. Okay, so this almost actually works out perfectly accidentally. There is a freeway that goes directly from one to the other, and it's almost perfectly straight because it goes through the desert. So let's say I want to look for the midpoint. Now, the midpoint formula isn't hard because it is a bunch of crazy calculations. The midpoint formula is tricky because it's actually 2 formulas. Okay, you have a formula for the x value and you have a formula for the y value. And the reason this gets tricky is because there's a comma here. And what usually happens is when I put that on a screen, it's sometimes really hard, depending on the size of your font, to tell whether it's a comma or a dot. And a comma in math gets treated very different than a dot, right? A dot is multiplication. And so this is not being multiplied. You want your answer to be a coordinate, right? That is an x value and a y value. So I'm going to take my 2 x values and add them together and divide. Now the m out front is just the name of the point. So I'm not multiplying by m, I'm not doing anything, it's just the name. I'm just saying, hey, like this is my buddy Dan. This is where he is. Okay, so m is the name of where we're going, and then we're going to plug in numbers and get a location for that place. So x1 plus x2 is going to be negative 4 plus positive 2. y1 plus y2 is going to be 5 plus negative 3. So negative 4 plus 2 is a negative 2. 5 plus negative 3 is positive 2. So our midpoint is going to be at negative 1, positive 1. Now I just sketched it, kind of accidentally guessed, and it is about right there. Okay, so if this was on a graph or on an actual map, I could go to the coordinate negative 1, 1, and right there right? It would be right around the freeway, and I could say, oh, well, let's get off at this place, and then we've both driven halfway. Okay, now is that practical? Would we actually do that? I mean, I would, but most people wouldn't. Okay, I know normal people would absolutely just say, there's like an exit at whatever. Let's just get off at that exit and I'll meet you there and it'll be close enough. Okay, so most of the time we aren't looking for exactly halfway, but there could be a scenario where we do. Okay. All right, let me erase that. All right, I'm going to do one more example. So let's take 4, 5 and -3, 1. Now, just for fun, I'm going to designate the first one as x2 and y2, and the second one as x1 and y1. And the only reason I'm doing that is to show you that it doesn't matter which one you decide is your first point and which one is your second point. Okay, I'm going to do this whole example without graphing anything. So my distance is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. So 4 minus -3 is a +7. 5 minus 1 is +4. That should be squared. So 7 squared is 49. 4 squared is 16. So the square root of 49 plus 16 is going to be 65. Okay. Now, 65 doesn't have a perfect square. If I put this in a calculator, I'm going to get like 8.1 whatever, okay, or around there. This is what we consider an exact answer. If XYZ asks for your exact answer, that's what they want. They want you to put in a square root symbol and a 65. Okay, now in XYZ, in the answer box, if they want something like this, there's going to be a little arrow right here on the edge of the box. It's going to be highlighted in yellow. If you hit that arrow, it will pull up a formula editor. And that editor is what's going to give you that square root symbol. Okay, it will give you a pi, it'll give you e, it'll give you a log, a natural log, right? All of those things that we're going to come across. It'll give you a fraction setup. It will give you all of those things so that you can type in the formula exactly the way you want it to see. Okay, so you don't have to learn how to like program and write in math to do this. You just have to have that. Okay. All right. Now, I could put that in a calculator. I could get a rounded answer. Don't worry about it unless they ask for it. Okay. So let's look at the midpoint. I'm going to take x1 and x2. So -3 plus 4 over 2, and then y1 and y2, so 1 plus 5. So -3 plus 4 is a 1 divided by 2. 1 plus 5 is 6. 6 divided by 2 is a 3. Okay. So answers-wise, those would be your exact answers. Okay. Now I'm going to let you try the last one on your own. So I want you to pause the video, try it, and then once you have an answer, I will, push back, put play, and I'm going to write the answers right here on the slide so that you can check your work and see if you're on the right track. Okay. So pause the video, try the last one. When you're done, unpause, and you'll see the answers. All right, so you should end up with a distance of 13 and a midpoint at 13 halves and 1. Now, if you wrote 13 halves as 6.5, probably also just fine. Okay, but improper fractions really aren't as bad as your elementary school teachers made them sound. All right, so that's it for 2.1. Make sure you do the homework, part in XYZ, part in Canvas.